Folks, good evening, good day. It's been another weekend and we've had a lot of fun with Kettle Beam again. Kettle Beam is Apache Beam integration for Kettle, Pdi data integration. And another weekend with some progress. So let me show you where you can find the goodies, and then we'll show you how to install Kettle Beam for yourself, and then we'll run, of course. So what you need to download is basically the plugin, and if you go to Kettle Beam project, here's the URL, and if you go there, you'll see the release. But because it's hundreds of megs, I put it up on S3 for you to download. You need this archive, this download, and you also need Pdi Engine Configuration. These three jar files in there provide run configuration support for Apache Beam in Spoon and in the engine. So download these and download version 8.2 of Pdi data integration. You can find this in Pdi 8.2 on SourceForge. You go to Client Tools and then download Pdi CE. Where is it? Here is the last one on the list. Pdi CE 8.2, which had the most downloads, 6,000 this week. All right, the size has risen to 1.2 gigabyte. It's just 100 megs short of 1.21 gigawatts. Anyway, so let's increase that amount a little bit more. So in here, I downloaded these things. Let me just show you. So I have Pdi Community Edition 8.2. I have the engine configuration file that I downloaded, and I also put in place some plugins. And this one I'm going to remove. We'll download this one. So what do I have? I have this zip file that I just mentioned, 272 megabytes. I have a tiny, in comparison, 42 kilobyte environment plugin from my repository on GitHub. You can download that also. The Kettle debug plugin that is convenient for people like myself that are using high DPI screens, 4K, and because that remembers zoom levels. And the Needful Things plugin is useful for fixing bugs and stuff. I always download this. And obviously data sets unit testing. I will show this in action actually in this video. So download these at your leisure, and I put them together in a plugins folder so that I can zip them all in one go. So let's get started. So first, let's do this quietly. So first, the community edition of Pdi data integration. That shouldn't take too long. Sorry about the blowing noises in my last video. I strapped on a little mic. Hopefully it's better this time. So in the data integration folder, we're gonna unzip our Pdi engine configuration file, and it's gonna want to replace three jar files which handle the engine configurations. So we're gonna replace them all. Then we go to the plugins folder, and let's just 4i in file in plugins. So every zip file, and we're gonna unzip those. There we go. And you can see that we added these plugins basically. I also have an 8.2 version of what I'm building here ready to download, but I need some more testing for that. So let's fire this up. Oh yeah, we also want to get the beam examples, right? So beam examples is also one of my repositories on GitHub, and let's just clone this somewhere over here, or you can download the source code of this thing and just unzip it somewhere. So let's fire this up. This takes a while because yeah, it's a 1.2 gigabyte behemoth these days, and it's mostly due to the large size of the big data plugin that's in there. It ships by default with an 800 meg zip file that is Kettle itself. I'm going to show you that Apache Beam has a little bit smarter solution for that, which could help tremendously in trimming down this whole mess. Well, it's only the first time that it's slow to start up. The next time it's quite a bit faster. Once there's a bit of caching going on. Alright, so the first thing I did, maybe that was a little bit too quick. The first thing I did was create an active environment, and so what you typically do is just type in the folder of the project that you want to work with. In this case, Kettle Beam examples. And Kettle Beam examples, maybe we can take a look at that for a second. Kettle Beam examples actually has everything in it that you need. It has data sets for golden data and input data to test with. So this is new for version 3.1 or something of the datasets plugin. It allows you to store all your unit test datasets in CSV format. Alright. It also contains some test input for the direct runners of. It contains a couple of sample jobs, and it also contains all the metastore elements that you need for your file definition, the Git repository, and everything in there. So it's completely self-contained, and obviously sample transformations that we're going to use to run with. Hope that clarifies. So the only thing we need to do is type in the folder name, and this defines the environment home variable throughout the whole project. And everything else, like the Methyl Metastore folder, which relocates the metastore to this folder, and yeah, everything else is based off of that. Alright. So once we select this, we can see that. Let me just open up this temp file. Transformations. Once we open this transformation, we see that we have unit tests defined. So the def unit test cases, they're used to develop again. So you can do previews with this. So this transformation is an extreme complex case where we push a lot of rows through this whole chain. And so we can test with this. If we also have a unit test for this, and so if you run this either standalone or through the run all tests step, you will see that it actually validates the output against the golden data set. What is also new for this version is that you can click on these arrows and you can see the field mapping and the sort order. So if you want to quickly change that, it's become very convenient to work with this. There are other things to click on. For example, if you know, you can see the environment that you're running on in big print. Actually, if you just do 100%, it's not that big, but so if you could click on this, you can quickly see which environment that you're in, and you can also edit this. What we're also doing is enforcing execution in the environment home. So if you're trying to execute a transformation or job in another folder that's not a subfolder of environment home, it will throw an error. That prevents you from executing transformations and jobs that do not belong to this environment. Alright, so running development jobs in production or vice versa is not possible this way. So what you also get from Beam examples is the file definitions. So we have two file definitions that describe these input file definitions and the output file definitions. So what you also get is a couple of default Beam configs, job configurations. One is something that you can use directly out of the box, which is the direct runner and the configuration for that. So the direct runner simply uses these parameters. So you can set a user agent, which is freeform. The temporal location is set automatically to environment home TMP, which is a folder you can create, I guess, here. I'm not sure if it gets created automatically. You can also specify which plugins to stage if they exist. You don't always need those. What you can also do is specify specific parameters, and we're using these to specify which input files that we're using. So all the no header 1K files for the state test and for the output, and this was a variable test in one of the transformations. Same for Google Cloud Platform, there's a bunch of settings I will go over in a second. So if you want to run this, you also need run configuration. So let's create one. Because of the patch, we now have, let's call this Beam Direct. And so we will use the Beam Direct Runner. So you can select the Beam job configuration here. So this is all we need to do. So we already validated that the transformation ran correct through the unit test. So now we can run this against actual data on Beam Direct. And what will happen now is that a Beam pipeline is being created and executed in the background, and it's already done. So what I also did is picked up all the metrics from Beam and populated this dialog with. Internally, I'm tricking like the existing transformation engine. I'm not actually running this. I'm letting Beam do the work. But in any case, so what we'll see is that the Beam runtime engine is actually plenty fast, hundreds of thousands of rows per second. So quite impressive, actually, quite a good performance. Let's try to run this on Google Cloud, which I configured as well. So for data flow on Google Cloud Platform, I basically provided a different temp folder. It needs this. You also need to specify a project ID, not the project name, but the project ID, and a staging location where it will stage all the binaries, all the jar files, and all the jar files, those are the ones from the Kettle Beam plugin automatically added, and it will also add all the libraries from the lib folder of your distribution that you're now running in. So no need to repackage that, it's done automatically. You can specify some workers, but it's probably best to leave that up to Google. You can specify the machine type. I created a list of all the current things in there. Depending on the size of your wallet and your needs, you can go to high memory machines or high CPU machines, stuff like that. Right? For this exercise, we don't need that much, but we also don't want to wait forever. You can also specify the region. So, for example, I could choose to run in Belgium. Here we go. I'm not going to do that. I'm just going to let Google cover that for me. And in this case, again, I'm just going to create a new run configuration. Beam data flow. And by now you know how this works. So let's run this thing again, and this time against the data flow. And so this initializing phase takes a bit longer because obviously Beam needs to upload all the data into the cloud, into the Google Cloud Platform storage. You can kind of see the pipeline being created and all the steps that are being handled. Now what's happening once the metrics refresh starts, what's happening is that Google is allocating new resources. So let's take a look how this looks. And alright, so my complex job is graph is still being analyzed. Here it is. So it's allocating the server, the virtual machine that I requested, or machines. I don't know exactly how this works. It's dirt cheap. That's all I can tell you. It's not as fast as a direct runner, but pretty cool nonetheless. And it's probably capable of handling quite a bit more data, right? So now it's doing all sorts of stuff, allocating things. And in the Spoon UI, you will probably still see this as being initialized. Once we'll start getting metrics, we consider the initialization phase done, whether it's for direct runner or for data flow or for the third option, the Spark engine that I have. So now it's idle and it's starting to run, so it's starting to process the first bits of rows, and this is signified in here. You can see the metrics here coming in. So now it's kind of flowing the data through the data flow pipeline, and you can see this visualized in Kettle using the typical grid. The input column here is not the same as what we're used to. I'm kind of abusing that column to signify the amounts of workers that were started for each of these phases. So the amount of process, the amount of times that this was initialized. This can sometimes be higher than you would expect because this is a fault-tolerant engine, so maybe something failed and it retried, maybe something ran out of memory, it retried, and then it succeeded. So that's completely covered by the engine in the background. What is being signified here are really the rows that were committed as being successfully processed. So it's just a small file of 1,000,000 rows of customer data, and it's pushing this all the way through. So it's a slow engine, but virtualized. So I guess it's normal. It's not due to the implementation, but more to the nature of the virtualization and this whole thing. So you can also leave this running and start working on other examples. It's pretty cool that you can use all these things like stream lookups, switch case, merge join is one. The group by step is still not finished. I wanted to get everything done architecturally because it's so much nicer to run this this way, right? What we can also do is run a job. So if you want to have any of these things run in a job, that is possible since we're offering integration. So let's take one of these examples. Let's take a simple one. Input, process, output. This one, and we'll select the direct runner for this one. Let's call this run being a job. So you can run this in a job now, and again you see the typical logging, and in the output we'll see all sorts of stuff. I named the output files the same as the transformation, so you can see the output here. And in the meantime, you know, there's already a few steps idle, and in a bit the transformation is probably already long gone and done. But this thing usually takes a bit to ramp up and shut down and do all sorts of stuff. So very happy with this environment. Very happy to see that we can easily switch back and forth between projects with the environment runner. It's very easy to just switch. You can configure the system configuration to enable this. There's a button here to add a default environment, and the default environment, yeah, you can set that to your own liking. Just leave it empty and uncheck this and force execution. So that means it's like standard, right? You can leave all that empty, don't define anything, and that's pretty much the default as you had it. But you will find out it's quite convenient to have these things. Alright, what else can I tell you about this? It's been pretty cool to work with this, and yeah, let me know what are the features that you want. Probably be working on other stuff this week. Maybe next weekend I'll fix that pesky group by step, because I think right now the only things that are supported is number of values and sum. But min, max, and the others shouldn't be too hard. The tricky part there is that it's kind of like you have to take intermediary steps to come up with the right solution. So you need to rework that beam integration a bit, because it's a parallelized group by. You only get like a small window for a certain key that you can aggregate. But the ones that I haven't implemented yet, I'll throw an error for those. So that's what I'm doing right now, so that yeah, so that you can see what's working and whatnot. All right. Hopefully this was. Let me show you the results as well on Beam. Those end up in the output folder that we selected on Google Storage. Here are the binaries that are uploaded. It's a lot of binaries, right? And I think that the ones that it recognizes, like all the Apache, all the standard libraries that it recognizes, it doesn't really upload. I think it's just keeping some kind of link or something, or just copies it internally from Google. And for the output, I think it's a complex output. But I've been running this thing for quite a bit, so these are the files that you can find. These are quite a bit bigger than locally. But in any case, hope you found this thing useful, and yeah, let's keep it at that. Give us feedback. Let me know what else you need for environments for any of the plugins that I demonstrated. And have fun with it. Have fun with Kettle. Ciao.